Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss atomic polarizability. Let's begin. When a dielectric atom means the atom present inside that of dielectric materials. The atom on which that dielectric material is made, we call it as dielectric atom, is placed in an electric field. It becomes induced electric dipole. Due to that induced electric dipole, it has a induced dipole moment, and the process of producing that induced dipole is called polarization of atom. When a dielectric atom is placed in an electric field, an electric dipole is induced. Due to that of induced electric dipole, it has an induced dipole moment, and the process of producing that kind of induced dipole is called polarization of atom. But in normal, if we prefer an atom, there will be no such induced dipole moment due to electron as well as proton. But if it is present in an external electric field, then the distortion may occur. In our observation, we see we found that induced dipole moment that is induced is directly proportional to the strength of applied electric field. Strength of applied electric field. That is induced dipole moment denoted by small p, which is directly proportional to the strength of applied electric field. Let that applied electric field E naught. Or a proportionality constant is used. P is equal to a proportionality constant, that is alpha E naught. Alpha constant of proportionality called, that constant of proportionality is called polarizability of atom. Polarizability of atom. Polarizability of an atom is denoted by that letter alpha, and that process of polarization when that atom is placed in an external electric field. In broadly, we can represent it mathematically by taking an atom. Let me take an atom. Let us consider an atom atomic number denoted by Z, and it has spherically symmetric, therefore the charge distribution is spherically symmetric charge distribution, and it has the radius smaller. In the absence of electric field, in the absence of electric field, let me assume that whole of the positive charge is concentrated at the center of the atom, at the center of the atom. That is at the nucleus, and whole of the negative charge is spread around in the form of spherical cloud. In the absence of electric field, what happened here? In case of that particular atom, we have to assume whole of the positive charge is concentrated at the center, that is center, which is also known as the nucleus. And the negative charge is spread around that of nucleus in the form of spherical cloud. They are the electron cloud. when there will be no such presence of electric field. But when we apply an external electric field, then the distortion takes place on that of electron cloud. In the presence of electric field, in the presence of electric field, then what happened? In order to create an electric field, let me choose a charged parallel plate capacitor. One is positively charged, another plate is negatively charged. Direction of that electric field from positive to negative, and it has the strength E naught, and an atom is present in between that external electric field having the strength E naught. It has the nucleus, that is the outermost shell. So, what exactly happened in the presence of electric field? Due to that presence of electric field, the positive charge will experience a force due to that of electric field, and the direction of that of positive charge along the direction of electric field means that positive charge moves towards that of negative end. We write the positive and negative charges will experience force due to this electric field. And the direction in opposite direction. Since the positive charge is concentrated on that of nucleus, and due to its large mass, its position remains fixed. but that negative charge cloud is dissipated, that negative charge cloud displaced towards that of positive plate of that of charged plate capacitor. Positive charges are concentrated on that of nucleus due to its large mass, but the negative charges are displaced, but negative charge cloud is displaced towards the positive plate of the capacitor. Charged parallel plate capacitor. Charged parallel plate capacitor we use in order to create an external electric field for that given atom. Let me take the distance between the centers of positive and negative charges, negative 1, positive 1, distance of positive and negative charges, let x. Here x distance between the centers of positive and negative charge. And the force applied on that of positive charge due to that external electric field, and that is along the direction of external electric field, and that is towards the negative plate, and that force we can calculate easily. The force acting on the positive charge due to applied electric field and that direction is towards negative plate of that of capacitor, and that force that is F is equal to charge into strength of electric field E naught, as E is equal to F by Q. So, F is equal to Q into E naught, or F is equal to total charge atomic number into electron E naught, where Z into E, atomic number into electronic charge is the total charge on nucleus. And that force acting on the positive charge is balanced by the force due to the negative charge cloud that contained on that of a sphere having radius small x. The force on positive charge is balanced by the force due to negative charge atomic number electron minus negative charge cloud that contained in a sphere of radius small x. Let you take volume charge density of that given atom, volume charge density of atom rho. The electronic charge inside that of volume, the electronic charge in volume it is 4 by 3 pi r cube, and that is equal to total charge contained in that volume 4 by 3 pi r cube, total charge contained in that volume 4 by 3 pi r cube, total charge Z into E. Therefore, volume charge density rho and total charge present in that of volume ZE. Therefore, charge per unit volume, electronic charge per unit volume, how much electronic charge present in that of unit volume ZE divided by that volume 4 by 3 pi r cube. The electronic charge in a sphere of volume 4 by 3 pi x cube is the total charge present in that of sphere having volume 4 by 3 pi x cube, that sphere having the volume 4 by 3 pi x cube. What will be the total electronic charge? It is ZE, electronic charge per unit volume ZE divided by 4 by 3 pi r cube into sphere having volume 4 by 3 pi x cube. 4 by 3 pi cancelled out. Electronic charge in that of given volume 4 by 3 pi r cube, q is equal to z e x cube divided by r cube. We have taken equation number equation number 1, that is equation number 2. Now, from Coulomb's law, we can calculate the electrostatic force of attraction between the nucleus and the electron cloud. From Coulomb's law, the electrostatic force of attraction between the nucleus and electron cloud is f dash is equal to 1 by 4 pi epsilon naught charge on nucleus Ze, electronic charge q divided by separation of distance in between these two charges, that is x square, or f dash is equal to 1 by 4 pi epsilon naught Ze divided by x square into value of q Ze x cube divided by r cube. On cancellation, f dash is equal to 1 by 4 pi epsilon naught Ze square x divided by r cube. Equation number 3. In equilibrium, these two forces are equal with each other. In equilibrium, F is equal to F dash, value of F Ze E naught Ze into E naught is equal to F dash 1 by 4 pi epsilon naught Ze square x divided by r cube, or E naught is equal to Ze into x divided by 4 pi epsilon naught r cube, or E naught is equal to QE, that is the charge, x the distance between the charge and distance between the charge. These two product is nothing but dipole moment, and that dipole moment is given by small p divided by 4 pi epsilon naught r cube, where Ze into x is equal to p, that is dipole moment, the induced dipole moment, or p by E naught, that p by E naught will be 4 pi epsilon naught r cube. From our definition, P is equal to alpha inert, whereas alpha is the polarizability of ungiven atom. Therefore, that alpha is equal to P by inert. Now, mathematically we show P by inert, that is alpha is equal to 4 pi epsilon naught r cube. Atomic polarizability. If there are n number of atoms per unit volume, if there are small n with the number of atoms per unit volume, then that polarization vector representing polarization vector density, polarization density, capital P vector, that is number of atoms per unit volume small n into small p vector, whereas alpha is equal to P by inert. For that we can use P is equal to alpha into inert. It can be written, this is the polarizability, polarizability. As P is equal to alpha into inert, small p is equal to alpha into inert, therefore polarization density capital P n into small p, that is 4 pi epsilon naught r q n inert vector or p vector is equal to, for that quantity we introduce alpha, then inert vector, that one is the polarization density. Where alpha is equal to that much 4 pi epsilon naught r cube into n, that is a constant. So, here with the help of this video lecture we understand the concept of atomic polarizability. What is polarization of an atom? Its defined mathematical formula. Mathematically we show it by taking an atom having atomic number Z and radius small r. What exactly happened in the absence of an electric field, and what happened in the presence of an external electric field. In the presence of an external electric field, an induced dipole is developed, and due to that induced dipole, it has induced dipole moment, and mathematically we show what with exactly that induced dipole moment, and the ratio of induced dipole moment to that of applied external electric field is nothing but atomic polarizability, and finally polarization density. So, with this useful and informative notes, let me wind up this session. Thank you.